What is light? A good question to start with. For many living organisms on Earth require light as a source for life, food, and survival. Please share this video with friends and family. Also, if you haven't subscribed to my channel, please do so now. Also, press the bell icon for future notifications. There is no single answer to this question. For a physicist, light is the source to understand the physical properties of it. For an artist, light is an aesthetic appreciation of the visual world. Through the sense of sight, light is a primary tool for perceiving the world and communicating within it. Light from the sun, the energy that warms the earth, drives global weather patterns and initiates the life-sustaining process of photosynthesis. On the grandest scale, light interacts with matter that gives or helps us to see the shape/structure of the cosmos. The source of light provides a window on the universe, from cosmological to atomic scales. Almost all the information about the rest of the universe reaches Earth in the form of electromagnetic radiation. By interpreting that radiation, astronomers can glimpse the earliest epochs of the universe, measure the general expansion of the universe, and determine the chemical composition of a star and the interstellar medium. With the invention of the telescopes has dramatically broadened our exploration of the universe. Similarly, the invention of the microscope opened the intricate world of the cell. The analysis of the frequencies of light emitted and absorbed by atoms was a principal impetus for the development of quantum mechanics. Atomic and molecular spectroscopies continue to be primary tools for probing the structure of matter, providing ultra-sensitive tests of atomic and molecular models, and contributing to studies of fundamental photochemical reactions.
Now, let's get into some interesting and actual facts on light. The speed of light in a vacuum is a fundamental physical constant. The currently accepted value, which is exactly 299,792,458 meters per second, or 186,282 miles, or 299,792 kilometers per second. The fun fact here is, if you snap your finger, the light would have circled Earth approximately 7.5 times. We must remember, light is an energy source, and the visible light in the electromagnetic wavelength makes up approximately 0.0035% of the entire electromagnetic spectrum. This tiny fraction in the part of the spectrum that humans can see, which ranges in wavelength from 380 to 750 nanometers. This tiny band, which I quoted 0.0035%, has high energy and low energy, where high energy is red and the low energy is violet. Therefore, the colors that we can see basically are red, orange, yellow, green, blue, indigo, and violet. This is the narrow band within electromagnetic wavelength the humans occupy. Now, the interesting part of the rest of the electromagnetic radiation that occurs over an extremely wide range of wavelengths are from gamma rays to the radio waves measured in. The electromagnetic radiation is used to observe the cosmos by utilizing telescopes that are sensitive to different parts of the electromagnetic spectrum, from radio waves to gamma rays. Each wavelength reveals different information about celestial objects, such as stars, galaxies, planets, and nebulae, allowing scientists to piece together more complete picture of cosmic phenomena. The advancement of science and engineering has developed telescopes to read different wavelengths of the electromagnetic wavelengths. For example, radio telescopes can see through cosmic dust and gas clouds that block the lights that we can read. And similarly, there are infrared telescopes that can detect cooler objects and see through the dust Similarly, there are ultraviolet telescopes which capture the energetic light that can indicate the process like stellar winds. Then X-ray telescopes which studies the extreme high energy phenomena like the accretion of a disk around the black holes and neutron stars. Gamma rays telescopes observe most energetic events in the universe, such as supernovae and the jet stream that comes out of black hole. Then the optical telescope, where we try to collect the visible lights from the stars and glowing gases. As these different telescopes reveal the intricacies of our observable universe. Therefore, anything that we observe are in the past, as the radiation or light we call, or energy that we detect are based on light years. That is an object, light that we are witnessing now was originated thousands or millions or billions of light years. A light year is measured in a unit of distance, not time, equal to the distance light travels in one Earth year. As we approximately call an Earth year is 365 days. So, what astronomers use this scale to detect a light photon travel in 365 days. The measurement is an immense distance, approximately 9.46 trillion kilometers or 5.88 trillion miles. The universe is vast that astronomers use light years to measure distances to stars and galaxies. The closest star to our home planet, which is we call the Sun, is about 148.3 million kilometers. The light that leaves the Sun takes 0.00015 light years. In other words, if you put it in time, 8 minutes and 20 seconds to reach Earth. The closest star to Earth outside of our solar system is about 4.24 light years, and we call it the Proxima Centauri. This is the closest, is part of the triple star system, which is known as Alpha Centauri A and B. When we observe Proxima Centauri, we are truly witnessing the star and the planets that orbit the star about 4.24 light years ago. You know how far is 4.2 light years? Is you need to multiply 4.24 times 9.46 trillion kilometers. Our brain cannot handle these immense distances, which is why light years are used as a scale to measure the far distances outside of our solar system. Within our own solar system, we use astronomical unit. Sometimes we call AU. 1 AU is approximately 93 million miles or 150 million kilometers from the sun. When we stare in the night sky, cold night sky, we see stars. All the stars that what we are witnessing are within our own galaxy, which is called Milky Way galaxy. Our galaxy harbors roughly 250 to 400 billion stars. Most stars have orbiting planets and moons. Scientists have observed already about 6,000 exoplanets orbiting nearby stars. Our closest galaxy is known as Andromeda. It's a spiraling neighbor, approximately 24 quintillion kilometers. It's, in other words, 24 million kilometers from Earth, or about 2.5 million light years. This immense distance underscores the universe's staggering scale, which challenges human comprehension. Andromeda proximity is merely a speck in the cosmic terms. The observable universe spans roughly 93 billion light years, containing over 2 trillion galaxies, each within 100 billion or even trillion stars with planets. Although Andromeda is situated about 2.5 million light years, it is yet gravitationally bound to our Milky Way, part of the local group, and the two galaxies may merge in about 4.5 billion years. The universe scales grow even more unfathomable when considering distant galaxies, some over 13 billion light years away. Their light only now reaching us from the early universe. This immensity humbles our place in existence, sparking awe and curiosity about the cosmos, while reminding us how limited our sensory and cognitive frameworks are in grasping its true scope. I hope you enjoyed this video. In my next video, I will talk about the spectrum light astrophysicists and astrobiologists try to use to detect whether there is life outside of our solar system, even within our solar system, to detect chemical compounds that are required for life. I am not a trained scientist, but I love science. Make us to be more curious. In a lighter note, all I gain from my understanding is how insignificant our Earth in this cosmos, but equally how significant we humans are, able to observe, test, interpret, and develop theories to understand our universe. Thanks for watching. Have a great day.